Okay, so we are on day 2 of summer school. Hopefully it went well yesterday and you were able to submit all of your work on time. So I'm going to share the work here. So for the first, it's a little bit too zoomed in. For the first lesson for organizing and displaying quantitative data, you do have 2 videos made by another teacher. And I will be doing the Scatterplot one, and then there's a linear regression one that's also done by that other teacher. So I'm just gonna zoom past here. If you see anything that needs any sort of special like graphing calculator, just skip over it. I don't expect you to have any calculator like that at home. Everything should be pretty straightforward, I hope. Okay, so we've got our scatter plot and correlation versus causation lesson. So you've got a video to watch on scatter plots. Please watch that before you start this lesson. If you have not, then pause this video and go watch that video. So while you're watching the movie, you should have answered the following questions. I'm going to go over the answers right now. Yeah. So what does a scatter plot show about the relationship between the number of powerboats registered in Florida and the number of manatees killed in by powerboats? So in the video, it said that there was a positive association between manatees killed by powerboats and the number of powerboat registrations. In other words, as the number of powerboat registrations increase, powerboat increases, the number of manatees killed also tends to increase. Okay, so in other words, if your powerboat wasn't registered, or the people that did not have their powerboat registered had high numbers of manatees killed, which is very tragic if you ask me. So why is the number of boats plotted on the horizontal axis of the scatter plot? So the number of powerboat registrations is the explanatory variable. Okay, and what trend would you expect to see in a scatter plot of 2 variables that have a negative association? So as one variable increases, that's not how you spell that, the other tends to decrease. For example, in factoring quadratics, the time it takes for you to factor a particular type of quadratic decreases with the number of times you have practiced factoring. So I'm sure you've heard it many times, practice makes perfect. So in this case, as one variable increases, the other one decreases. So the more you practice, the less difficult questions would be. So as I'm saying, the more you practice, the faster you get. So you would see that scatter plot go on a downhill type thing. So just as a note, a scatter plot of manatee deaths and the number of powerboat registrations shows a positive association between the 2 variables. However, the fact that there is a relationship between two variables is not sufficient evidence to prove cause and effect linkage. So in other words, it doesn't mean that if you don't register your powerboat that you're going to go on the lake and kill a manatee, right? It's not a cause and effect type of thing. It's just almost a coincidence. A well-designed randomized experiment in which the researcher imposes some threat on its subjects to see how they respond is the only way to give good evidence for cause and effect, as you will learn in the next unit. So we've got some scatterplot basics. So remember that quantitative variables are measured on using numeric values. So meaning on a scale of 1 to 10, how was your breakfast this morning? So that uses numbers. So quantitative means numbers. Maybe if you put that down with a little star. When you have two quantitative variables, so bivariate data, you can use a scatter plot to examine the correlation, so the association between two variables, or I can't think of another word. In many cases, changes in a variable X are thought to explain changes in a second variable Y. In such examples, X is called the explanatory or independent. So independent is your X part of your graph. So for example, it doesn't depend on anything. So one that we see often is things like time, age. So time just goes on its own. It doesn't depend on something to move forward. Same with your age. So each day you're 1 day older, and that doesn't depend on anything. And Y is called your response or your dependent variable. So in other words, as you get older, something happens. So you get more wrinkles, for example. So that would be your dependent variable. So you would say, like, by the age of 60, you have 10 wrinkles. So that depends on your age. And then by 70, you have 15. A scatter plot is a plot of observations of quantitative variables X and Y as points in the plane. The explanatory variable, again, your independent, if any, is always plotted on the x-axis of your scatter plot. So same as any plot that you would have made in any other courses for math. Your x is at the bottom, your y is your vertical going upwards. I'm going to clear this. So in the video on manatees, the explanatory variable was, so that would be the number of powerboats. Okay, so as you see your scatter plot here, this is your independent variable. So the number of powerboats sold or the registrations. So that doesn't depend on anything. It's just people want to buy powerboats. And then your dependent variable or your response variable would be the number of manatees that were killed. Okay, so that would depend on how many number of powerboats. So I'm going to clear this. Okay. So we've got correlation. So that means like the relationship between the two parts. So when analyzing a scatter plot of bivariate data, we look at the overall pattern. So is it linear? So linear is a line. Is it curved? Meaning it looks kind of like a U shape, or is it just random and all over the place? It looks at the direction. So if it's positive, if it's going upwards, or if it's negative, it's going downwards. The strength of the relationship. So is it strong? Is it moderate? Is it weak? Or there's no correlation? So strong meaning all of your plots would be close together. Moderate would be a little bit further apart. Weak would be kind of all over the place. And no correlation would be seriously all over the place. So a pattern is a scatter plot that has linear form. So again, linear would be like this, so a line. When the dots appear to be randomly scattered on either side of the line. However, sometimes the data form a curved pattern. So your curved would be something like this, or it could be like that. In that case, we say the scatter plot has a non-linear form. So I'm going to clear this. Okay, so for example, here we have a linear form. So if you were to take a line, I thought I could. Yeah. So if you were to take a line, it would follow a certain kind of pattern. So that's linear, whereas the one beside it does a kind of curved system. So that would be a non-linear form. So two variables are positively associated or correlated when above average values of one trend to accompany above average values of the other, and below average values of one tend to accompany. That's a lot of words. So in a scatter plot, it would appear as a pattern of dots in the lower left to the upper right. So in other words, your line would be going upwards like this. That means it's positive, it's going up. Two variables are negatively associated when above average values of one accompanied below average values, blah, 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 blah. In a scatter plot of negative association would appear to have upper left to lower right. So your line would look like this. It would be going downwards, and that would be negative. So I'm going to clear this guy. So here you've got your positive association. So like I said, it's going upwards, whereas this is negative and it's all going downwards. Your strength is where we see that strong, weak, no correlation, moderate. So your correlation can also be strong or weak, depending on how close or spread out the points on the graph are. If there seems to be no trend in the data, we say that there is no correlation. So if we look here, the dots are close together, and it makes a very clear line that's positive. And so we say that that has a strong correlation. If they're kind of spread out apart, but you still see the form of your graph, then that would be moderate or weak. And then when there's absolutely no type of form in your graph, that's no correlation. So graph 1 shows a strong correlation than graph 2 because the points are closer clustered together. Graph 3 shows no correlation. So I'll get you to try the examples on your own. So pause this video real quick and to give it a shot. So hopefully you've done pretty well. So circle the independent variable for each pair of variables. So your height versus your stride length. So your independent would be the stride length. Exam score versus study time. Study time is independent. It does not depend on your exam score. Although if you do better on your exam, obviously you're going to want to study more and do well the next time as well. Smoking versus cancer rates. So the smoking would be your independent. Absences versus final grade. Absences are independent. And annual income versus age. Age would be the independent. So your annual income would depend on your age in this case. I'm going to clear this and we're going to look at the types of correlation for the scatter plots, which does not look fantastic to me here. So for the first one, it is a strong correlation because all of your dots are close together. It is positive because it is going upwards, and it is linear because it's a line. The one beside it is also strong. It is negative because it is going downwards, and it is linear. The following one is weak. It is positive and linear. Weak, negative, and linear. And this one has no correlation. So your pattern is that strong, weak, moderate, no correlation. The direction would be positive or negative. Oh, sorry. Your pattern would be the linear curved, whatnot. And then your strength would be the strong, weak, no correlation. So I'm clearing this. As for example 3, we have the Avengers Infinity War had a successful opening weekend by earning more than $250 million. In opening weekends, a movie opening gross income is a way of predicting the movie's eventual success. So how many people go to see it on opening day, how much money they make, really depends on how the movie is going to do. If you go see a movie for the very first time, you're going to come back and you're going to tell your friends, oh my God, Avengers was awesome. And more people are going to go and they're going to make more and more money, which depends on, or which will help them with their money. So can you predict a movie's total gross income from its opening weekend gross income? Okay. So we've got how much they made on their opening day here for each movie. We've got The Martian, Star Trek, Lego, etc. And then we've got their total gross, so how much they made since that release date. So it's asking you to make a scatter plot of this. This is where it's going to get tricky on a computer. So your independent is the opening weekend gross revenue. That does not depend on anything. It does not affect the data. On this side, we've got lifetime gross revenue. So this should be turned sideways. I don't think I can do it now. Just leave it like that. So here you would number them. So you would have your $0 here. We're going to do it by 50 million. 50 mil, 100 million. Um, 200, 250, and 300. And then on this side, we'll do it by 100 million. 100, 200, four, 5. So looking at your table, you would put your dots accordingly. So I'm just going to do them quickly. So we have one here. I wonder if I can just do this. We have another one here. Another one here. So hopefully you remember how to put dots on a graph. Seven. And then your last one up here. If you throw them into your scatter plot like that, again, it's a lot easier to do on paper. And then you're going to want to throw in a line of best fit. It's not going too great over here. Nope. So our line of best fit would look a little bit like this. So I'm going to clear this. So describe the trend of the data. So that is where we look at if it's weak, moderate, strong, no correlation, positive, negative, linear, curved. So our pattern, our direction, and our strength. So their peers. Their peers be a moderate, positive linear correlation between opening weekend revenue and total gross income or revenue, sorry. The more a movie makes in the opening weekend, the more money it will gross in total. So use a trend line to predict total gross revenue. So using the trend line on the graph, the predicted total gross revenue is about 725 million. So you would look at your graph, and you would look at that line of best fit and where do you think it's going to go over time. One way to find the actual amount is to look at the predicted total revenue is equal to 2.27 times the opening weekend revenue plus 138,459,525.22. So that would give you exactly 723,434,460 as the total gross revenue. I hope that makes sense. If you have any questions, the Microsoft Teams is open. You can message me on there. Yeah, so good luck with everything today.